Hello, everyone, and welcome to the June edition of the YouTube Global R&D. My name is Rüdiger, and I am part of the Boundary Node and the Node team, and I'll be the MC for today's session. We have a pretty packed agenda, so I'll not go into the details of what you will hear about today. But be sure it's very exciting, and it's really worth it to stay until the very end. And yeah, without further ado, Adam, please take it away with updates on the ICCDK.
All right. So today I'm talking a little bit about the new Executor changes in the Rust CDK version 018. Previous Global R&D went over the changes to the call API. The Executor is a little bit of an obscure component because asynchrony is abstracted away as just marking your function async so you can await. But an async function returns a state machine, and there's a component of the Rust CDK to drive the state machine forwards. So the Executor's been through a few revisions, and the latest one is about scheduling. Historically, the Executor has not been capable of scheduling. Whatever you asked it to do, it would do immediately, whether that be running a new feature or continuing an old one that had suspended. This worked okay for the async canister calling API, but users often try combining it with async abstractions like channels, and those expect to be able to do certain things in certain contexts and produce spurious panics when they try. So for broader compatibility with the async ecosystem, the Executor has been changed in 018 to resemble conventional executors like Tokyo. This means the execution order changes. The code in an async block no longer starts running immediately, but waits for the code that called it to end or to suspend at an await. Now, a lot of code was written for 017 and before that depends on its ordering, so there's a spawn 017 compat function so that this code can upgrade smoothly. When you upgrade to 018, you can replace non-trivial spawn calls with this function, and then upgrade to the new spawn function one at a time and test for behavior changes. Saying that might make it sound like you have to worry about silent breakage, but don't worry, you do not. Your existing code should work exactly the same. Moving to this new function will just clear a deprecation warning. Next slide, please. It's worth looking a little bit at what the abstracted part turns into. In both versions, the update macro creates a regular function which sets up the Executor, then calls spawn. In 017, the only thing that needed to be set up was the panic hook, so panics gave you nice messages in your traps. Otherwise, you could just spawn a future. But in 018, this has changed a bit. So now the whole body of the function is put inside this in-executor context closure function. This allows the Executor to know exactly what's going on by associating global state with the running future, such as knowing whether it's in a query or update context. It also tells the Executor exactly when to start running futures that were scheduled. Once the inner closure has returned, the Executor starts running all the futures that are pending from this call, and only then does the outer function return. This may not be relevant to most users, but if you are eschewing the macros for whatever reason, this is the new boilerplate for you. Next slide, please. So with the internals being more compatible with the async ecosystem, you can use some abstractions that caused problems before. Async channels and barriers and cancel tokens and libraries of that nature previously would produce spurious panics, but now do not. Future aggregation types like futures unordered also work correctly, though some of these things mostly worked previously and only broke in some edge cases. However, these also make it possible to cause problems for yourself that you couldn't before without panicking. In particular, it's possible to deliberately create a background task that suspends during one method and resumes during another. The Executor works fine in these cases, but your code may produce surprising behavior because all the global state changes to match the new method, and panicking from this supposed background task results in the method erroring. We expect to introduce a guardrail around this in a future version, and this is me just warning you off of an intentional code pattern. This isn't something you can do by accident. Finally, there are some packaging changes. The Executor is now part of a new crate, ICCDK Executor. This crate is 1.0. We don't expect to make any breaking changes to it, and it does a couple things for us. First, it ensures that every future release of the CDK is using the same instance of the Executor, and the global state isn't being duplicated. Versions before 018 have had this benefit backported as well. They depend on ICCDK Executor 0.1. And second, it exposes a little more of the guts of the system, allowing people with very bare metal use cases like Azel to access the canister callback and trap cleanup logic directly, which you were not previously able to do. And that's it from me. Thank you.
Thanks a lot, Adam. And now next up is Jorgen from CycleOps, and he's talking about the very nice collaboration between ICP Ninja team here at DFINITY and the CycleOps.
Great.
Jorgen, take it away.
Thank you, Rudiger. Hello, everybody. Hello, ICP Belgium. Okay, next slide. Let's begin. So a couple of months ago, my co-founder Byron and I put together a vision deck about what a zero friction developer experience would look like on ICP. And when we pitched that deck to the ICP Ninja team, we found out pretty quickly that we were very aligned and that we had the same passions for developer experience on ICP. And even further, they demoed for us even several months back that they could deliver a lot of the things that we have on that milestone with ICP's current version. So we knew that we wanted to work with this team to build something really cool. So next slide, please. So obviously, it's uncontroversial to say that canisters are the core building block of people shipping things on internet computer. So I think it follows that the best practices and tools for working with your canisters are critically important. And there's actually quite a lot to learn about canisters. So we could ask the question of if we could make a new developer on ICP, their first canisters come with good tools and best practices. Wouldn't that mean setting them up for success in their ICP development journey? Next slide. So in this release with ICP Ninja, you can now deploy to canisters that you own. So ICP Ninja, if you're not familiar, is a great place to try out Motoko or Rust and build things on the internet computer. But before this integration, you could only ship to a canister that lasted for 20 minutes. That was great for trying out Motoko and Rust, but didn't mean you were deploying to your own production infrastructure. So with this release, not only will you be able to deploy to infrastructure that you own from right inside the web IDE, but those canisters that you deploy will also come out of the box with a degree of automation, so automated top-ups and monitoring and CycleOps built in. So this means that the new developer who's just getting started on the web IDE won't have to worry about things like silently running out of cycles, because CycleOps is going to automatically make sure they stay topped up and send email notifications to the developer before anything bad happens. Next slide. So it also means that ICP Ninja is leveling up as an integrated development environment that's truly native to the internet computer. So we've shipped a minimal canister management experience right into the application. So right next to my code, I can see the canisters that are running my code, and I get an overview of whether or not they're healthy or if there's something that needs my attention. And we've simplified canister management to the point where we're going to provide you with estimates for what is my runway on these canisters, or when will they next be topped up. And of course, if you want to get a fully, a full suite canister management experience, you can jump into your CycleOps account where your canisters are automatically synced for more advanced canister management that you need to perform. And you can do all of this directly inside your IDE. Next slide. Okay, so what did CycleOps actually build for this integration? Essentially, in our product suite, we already have all of these canister management tools. We have cycles management and top-up rules. We have monitoring and metrics, team access, canister creation, and so on. So our project for this integration was just to build a way for external applications to utilize that functionality. Next slide. So what we built is a little protocol that allows the user to link their accounts together. So from ICP Ninja, I can launch sort of like an OAuth-like flow on CycleOps, and after which that external app is going to get scoped access to the CycleOps account of the user. So we also then built an API on our canister that provides the functionality that allows ICP Ninja to provide estimates, to get canister health, and also to do write functionality like adding canisters or updating canister settings. Next slide. And if you'd be interested in utilizing that API, please reach out. We'd love to help you get access to it. Only had a few minutes today, but if you want to check out a demo, you can go to our X account at CycleOps or scan the QR code. And most importantly, there's free stuff. So if you go there, you'll see on the Twitter thread that there's a way for you to get a free coupon code so that you can publish some canisters for free. And that's it for me. Thanks, everyone.
Thank you, Jorgen. Free stuff is always good. But in general, super nice integration into ICP Ninja. It looks really nice. And next up is Sam with an update on the IC roadmap.
Thank you. Thanks, Louis. Hello, ICP community. My name is Sam. I lead the engineering team at DFINITY, and I'm going to give a brief update on the roadmap. If we can please go to the next slide. Thank you. So already at the end of the first quarter, we gave a bit of an overview of what we have achieved, and we do the same now as we are already at the end of June, so halfway through 2025. And you may remember we have presented a roadmap at the beginning of the year, which is split into 9 different themes. And to quickly recap them, so we have compute platform, decentralized AI, chain fusion, privacy, platform decentralization, identity, digital assets, governance and tokenomics, and last but not least, developer experience. And so within all of those themes, we have presented a few milestones, and we have already reached some of them in Q1. And actually in Q2, we reached more of them, and some are just a few days around the corner. And so today I'm going to give you a quick update on AI, chain fusion, privacy, and identity. So let's please go to the next slide. The big topic in June, and also what will keep us busy in July and beyond, is caffeine. In our roadmap, this is the Vertex milestone, that is the alpha release of caffeine. Back in June, there was the World Computer Summit, and the big news there was a demo of caffeine. It's a chat-like experience to write, evolve, deploy smart contracts which feel like a normal application on ICP, and that received a lot of attention. And we worked very hard to get there, and it was hardly a break. We actually continue because the next milestone or the next event is just less than a month away, and that is on July 15th. We have the event Hello Self-Writing Internet taking place in San Francisco. So there has even been some billboards spotted, so you can see that we take this quite, we go to town, we make a big splash here. And so if you happen to be in the Bay Area, or also if you want to join us from further away, there is an invite link in Luma. So please join us, and there will be a big event in San Francisco. So let's go to the next slide. We have not only worked on caffeine, we have also made good progress on some other big projects that we have been working on for several months. And in Chain Fusion theme, we have launched the Solana integration, or the Solana RPC canister. We presented an early version of this at the end of May, have meanwhile released the canister. It's under NNS control. There is a lot of training material. You see here a link or a picture of an educational talk by Gregory. So I encourage you to take a closer look at the Solana integration. And this is now our third big integration after Bitcoin integration, Ethereum integration. Now there is the Solana integration. And to not only talk about our own stuff based on such technologies like the Solana integration, there is some really exciting projects that were launched. For example, the Liquidium protocol. This is an instant loan protocol where you can using your Bitcoin. This was already launched, and they have announced in Vegas a cross-chain loan protocol that will be released a bit later this year. So that shows what is possible with the work we have released. Then let's go to the next one, please. In the privacy space, we have the vet keys milestone called Niobium coming up. At the end of May, we presented the test keys for this. There is also an SDK and a lot of example code that we have already released. And vet keys, as a quick reminder, is this protocol to derive keys so that you can encrypt data on the client side in your browser and then share it with other users that also interact with this app. And the the production keys have been created this week, and early next week they will be usable for everybody, which then is this milestone. Another topic that is always coming up when we talk about privacy or confidentiality is the trusted execution environment, TE. And earlier in May, I want to just point to this presentation where we presented a much more tangible roadmap to releasing or actually making use of the TE hardware that is in the nodes of the internet computer. So that's work we work on, and there is a lot of exciting releases coming up later this year. Then let's go to the last slide. Identity. I'm not going to talk too much about this because we have our team presenting much more details about the II UX overhaul that will then result in the Pulse milestone. It's a very exciting change, and it shows that we focus this year very much on developer and user experience, lowering the entry barrier. And so getting access to an app, if you use internet identity, will become significantly simpler, less steps, and hopefully less confusion. So that's internet identity. And then to the final slide, just wrapping up again, I hope you see that there's been a lot of great results and milestones achieved, not only caffeine, but also in some other key areas that are important for ICP. That's it from my side, and back to you, Rudi.
Thanks a lot, Sam. And with this, we wrap up the update section and switch to features. And Andre is going to tell us how Rust and Motoko can become best friends. Over to you, Andre.
Thank you. Hello, everyone. I'm Andre from the execution team, and today I'll provide a brief report on our recent exploration of the WebAssembly component model and the WebAssembly system interface. Our exploration was driven by three main questions: how we improve the developer experience, how to increase ICP adoption, and how to reinforce the ICP security. We'll get into the specific why and how shortly, but the most important takeaway is this. The WebAssembly component model is how we unite the ICP ecosystem, enabling languages like Motoko and Rust to work together while making the entire platform more secure. We are about to cover many technical details. Don't worry, there is a QR code on the screen with a link to a forum post where you can find all the information and share your feedback. Now, on the next slide, please. Let's talk about some challenges in the ICP ecosystem. First, choosing between Rust for its variety of libraries and books and tutorials, or Motoko for its simplicity and native candid support is a binding decision. It locks developers into a specific language ecosystem, sometimes limiting their access to libraries and ICP functionality. Second, the Motoko ecosystem is still maturing, with just over 200 packages on MOPS. More packages are essential for Motoko growth. Last point, ICP doesn't have a safe way to run a third-party or user-provided code. This can be limiting for some use cases. So how to solve these problems? On the next slide, please. Let's first review the current ICP development process. First, we build the WASM binary using a CDK and our source code. Then we deploy it on the ICP and call it a canister. Every canister has a heap memory, but Motoko and Rust manage that heap differently. This is why they can't be mixed in a single canister. So currently, developers are forced to choose one language per canister. On the next slide, please, let's see how the component model dev process will look like. First, we built two separate WASM components, for example, one in Rust and another in Motoko. The individual build steps don't change at all. We use the exact same tools and dev environments as we do today. Next, a new compose step combines these two components into a single WASM binary, which we deploy on the ICP. As a result, a single canister now has two separate heaps. Each language manages its own memory, so Rust and Motoko can finally work together. This composition is handled automatically by the WASM toolchain for all supported languages, but for advanced cases, we can compose it manually with a WebAssembly composition file. On the next slide, please, let's consider how these two components written in different languages actually talk to each other inside a single canister. The answer is canonical binary interface. It's a WebAssembly standard binary encoding for complex data types like strings, vectors, structures, enums. It works by preventing direct memory access and instead safely copying the encoded data between components. To make this process seamless, the component model uses interfaces defined with with files to specify how components interact. Based on these definitions, the WASM toolchain automatically generates the bindings. This is the glue code that converts data between the canonical and language-specific formats. On the next slide, please, let's see how does the component model solve the changes we discussed earlier. First, it brings unification. It allows us to build cross-language canisters so we can mix and match Motoko and Rust components. This ends the ecosystem fragmentation. Second, Motoko developers get access to the huge world of Rust libraries, which greatly expands what they can do. Finally, it delivers security through virtualization. By design, components are fully isolated, and we gain the ability for one component to securely manage and control another. This is a big step forward for on-chain security, and to illustrate this on the next slide, please, here is a specific security example. A trusted main component written in Motoko controlling an untrusted library component written in Rust, both running inside the same canister. The components are fully isolated and each has its own heap memory. The main component provides a virtualized messaging API to the library component, so the main component acts as a proxy. For example, a call from the library component to the ledger canister would be rejected by the main component, but a call to a canister B would be forwarded to the ICP. The result is powerful, fine-grained control over all component permissions. On the next slide, please, let's define what a minimal but useful component model implementation would look like. While the model supports multiple components, we propose starting with just two WASM32 components per canister. This initial version would deliver the most critical features: integration between Rust and Motoko, full isolation of trusted and untrusted code, and the ability for one component to securely control another. Then we would add support for 64-bit components, and in parallel to this core platform effort, we will also bring with bindings to Motoko and adapt our SDK to support components. Later, we will look into providing WASI Preview 2 support. And speaking of WASI, on the next slide, please, let's briefly look at what WASI actually is. WASI is essentially a standard system API for WebAssembly. The original version, Preview 1, was designed for general-purpose systems with features like file access. It's similar yet different from ICP's native concepts like stable memory. A community project called WASI2IC maps these WASI calls to the ICP system API calls. With this WASI2IC polyfill, we can run WASI Preview 1 binaries on the ICP. However, Preview 1 is now history. The WASM community has moved on to Preview 2 and 3, which are built on top of the component model. This means our component model implementation is the key that unlocks support for modern WASI on the ICP. Supporting WASI is critical. It keeps ICP aligned with the mainstream WebAssembly development flow. It brings more languages and libraries and expertise to our ecosystem, keeping it powerful and united. On the last slide, please, here is our status. We've completed the initial platform exploration with more research needed for Motoko and SDK. Assuming positive community feedback, we hope to begin the component model implementation this year. After that, we'll explore supporting WASI Preview 2. We are looking forward for your input on this. Please use the QR code with a forum link to share your feedback. And we are excited to see a new era of cross-language integration on the ICP.
Thank you, Andriy. I'm also very excited about this new era, and I'm also very positive. So let's see what the community thinks. With this, we're already at the demos, and as Sam alluded to, we start with the new Internet Identity 2.0.
Thank you so much, Rudy. My name is Andriy from the Identity team, and it is my great pleasure to finally be able to show y'all what we've been working on over the past few months. And for that, please, the next slide. So, Internet Identity 2.0, no more identity numbers. Yes, it is true. After 3 years, we can finally say goodbye to having to remember identity numbers. Why? We wanted to allow users to simply be able to recognize their identity by a name that they chose, which is much easier to remember, especially if you're juggling a lot. And we do this by implementing discoverable credentials, WebAuthn level 3. Multiple accounts. So you may want to log on to a DApp as a different person while retaining the same identity and same credentials, which should simplify your life quite a bit. And we have implemented this with per identity, per origin, additional accounts that simply give you a different principle that is presented to a DApp. Google sign-in. So very, very simple, easier sign-in and IC onboarding, especially for Web 2 users. Research has shown that passkeys even are still a bit of a scary black box for a lot of people. So being able to just see a familiar button and being able to sign in with Google and maybe in the future other OpenID providers should go a long way in increasing adoption. So yes, we implemented OpenID Connect authentication, which is entirely optional. So if you're scared of the privacy implications, don't worry. You don't have to use it. And last but not least, a very sleek new look designed by our wonderful design team. And in order to align with recent design developments, give a really new, fresh, and high quality feel to also align with the caffeine release. And yeah, how do we do that? We did a complete front end redesign and rewrite because it was necessary to implement the design that we had in mind. And with that, I hand over to my wonderful teammate Thomas for the live demo of the new authorized flow as a taster for what's coming.
As you can see on my screen, you can see that we have a demo website, try.id.ai. We got a new internet identity, also has a new domain name. And it is technically already live today on id.ai. And on the try.id.ai, you can try out the experience for yourself. And I will quickly go to the sign up flow and later to the multiple accounts flow. So within this demo page, you see a big white button to try the production version of Internet Identity 2.0. But for this demo, I will go to the beta version, like that's more up to date. So when you authenticate with the app, which I just initiated, the first thing you will see in the screen is a straightforward question. Do you want to continue with a passkey or a Google account to authenticate with try.id.ai? At this point, let's demo the passkey. So I say continue with passkey, and it will ask me if I already have a passkey. In this particular case, I don't have a passkey yet, so it says set up a new passkey. And then it will ask me to name my identity. It doesn't have to be your actual name. It can also be a nickname. But in this particular case, I will say Thomas. And then I will create my passkey. After the quick authentication, I am off to the races. And it will say that my identity has been created. It will redirect me back to the app and I'm authenticated. Simple as that. So user onboarding is a lot less friction, a lot quicker. You just type your name and you go. In the case of Google, you don't even have to type your name. You just select your Google account and you're there. So now I'm a user and I'm authenticating again with the same app, and I can actually choose accounts. So earlier I mentioned the feature of multiple accounts. particular with something like WASI, this allows you to have multiple addresses. But it could also be like multiple accounts on like a social platform. By default, you have the primary account. This is the same account you always had with Internet Identity 1.0, but you can decide to create another account. So by selecting that, I'll end up on the screen. Authenticate. I should not authenticate. I end up on the screen, and I have a button to create an additional account. So there I can say this is a work account, and I say create account. After which it's created, and now I can choose to authenticate the private account or my just now created work account. And by clicking on the work account, I'm redirecting back to the app, and you can see I have a different principal. So next time I authenticate, I can choose between either work or primary account. Now I can switch back to primary, and I'm back in a primary account. Let me just redirect back. And after redirecting, you can see that you have one internet identity with multiple accounts. I think my internet is having issues for some reason. Yeah. And for users that have multiple internet identities, you can still switch between those. On the top right, you can see your name, and you can switch between multiple identities or add another one to the list through this flow. And that's it for the demo. I would like to invite everyone to go to try.id.ai and try out the flows for yourself. If you're a developer and you want to try out these flows within your dApp, you can already use the id.ai URL within the off-client configuration to try out the flow directly with your dApp. And that's it for my demo.
Thanks a lot, Thomas. And just briefly, AI 2.0 preview is live on try.id.ai again. And of course, we have much more coming soon with a fully redesigned dashboard and many new cool functions and a wonderful new design. So stay tuned. And with that, back to Rudy. Thank you so much.
Thank you, Andre and Thomas. So you're saying once I finally got around to memorizing my identity number, I need to forget it again.
You can still use it if you want as an
Amazing. And then next up, we have Jason, who is talking to us about the CanBench Instruction Tracing. Jason, take it away.
Hello, everyone. My name is Jason from the governance team, and today I'm going to give a demo of the instruction tracing feature in CanBench. Next slide, please. So first, I'd like to provide some background. As you might know, CanBench is a benchmark tool for Rust canisters, measuring instructions and the memory used by any workload defined by the user. But why do we care about benchmarking? And in this specific case, the instructions used by the canisters. Well, one reason is to avoid hitting the instruction limit. And for people who write code that runs on application subnets, I imagine they would like to reduce instructions and therefore cycles cost for their canister. Therefore, in both cases, I think it makes sense to have benchmarks measuring the canister code, especially those might cost a lot of instructions. Finally, what are the instruction traces? Well, when you use CanBench without tracing, it mostly gives you one number, that is the number of instructions used by the entire workload, which might involve like calling other multiple functions, which in turn calls other functions. But the instruction traces shows basically a flame graph for the instruction cost for every function called during this workload. Next slide, please. Okay, now with the background in mind, let's talk about this feature. The what is pretty simple. So given an existing CanBench benchmark, you just need to add an argument instruction tracing, and the flame graph will be returned to the file system, and you can look at the flame graph. As mentioned in the previous slide, the main purpose is to more easily understand, debug, and validate our benchmarks. But more interestingly, you can also use it to understand more about the canister performance in production if you have the production data and this is what I will demo later. I just want to briefly mention how there is actually an existing tool called IC Volume, which is used for things like adding metadata to canisters and so on. But it also has an experimental functionality which instruments the WASM, so that calling any update call on a canister will result in traces written to the canister stable memory, and it can be retrieved later. So actually, the first iteration was just to integrate IT WASM instrumentation with CanBench, and later the functionality is ported to the CanBench and making some improvements so that it works better within the CanBench environment. Next slide, please. Before the demo, I just wanted to introduce some concepts that's needed for understand the demo. The registry canister is part of the NS, which stores configuration data of the network, such as nodes and subnets. And the invariance check, it actually runs on every configuration change to make sure certain invariants hold, given the entirety of the configuration data. And as you can imagine, this computation can be quite expensive. So let's switch to demo. May I share my screen?
Yeah, go ahead.
Thanks. Can you see this screen?
Yes.
Okay, so this is actually the benchmark. Let me know if I should zoom in more. So this line is actually the entire workload that's under the benchmark. Let me run this. So a note in the monorepo we use Bazel, so the command looks a bit different, but under the hood is the same thing, calling CanBench. So the benchmark tells you that so the invariance check takes 2.6 billion instructions, which is quite a lot. And so while we run this, we can actually take a look. So this function actually calls a bunch of other functions. And if I were to try to improve this, it will be hard for me to know where to start. Okay, I think the run finishes and it tells you that it's written some SVG graph, and I have it open on the browser. And if you look at it, at the bottom, this is the benchmark. At the bottom is the top of the call stack. And this is the function in the benchmark. And the interesting thing is that the first two checks actually takes about 80% of the instructions. So if I were to try to improve this, I will know that I will probably not look past the first three, since like at most I will get about 10% improvements. So let's assume that we looked at the first one. There's not much to improve there, and let's look at the second one. So in order to improve this, we probably need to understand the code, but let's say we do, and we found that this line can be improved. As I run this again, I will try to explain what it does a little bit. So for the more technical people out there, so this is a B-tree set merged with another B-tree set, and this is in the for loop, and the set is actually getting bigger and bigger. So in this case, oftentimes extend is better than append when merging a small set into a bigger set. It takes a while to compile. Okay, now we know that the improvements is about 1 billion instructions, which is quite interesting. And if we look at the graph again, we can see that the second bar is actually mostly gone. I think that's it for the demo. So I hope this will be useful for people who write canister code. Let me stop sharing. Could we go back to the slides?
Yep, we're back.
Okay, yeah, next slide. I just wanted to thank a few people who helped make this happen. Yan for the IC WASM instrumentation feature, Islam for initial code review and guidance, and Andre for the final code review and helping it to take to the finish line. That's it from me. Thank you.
Thank you, Jason. Very nice also that you can spot such a small change has such a big impact in the end. And with this, we're actually already at the last part of today's Global R&D, a community demo from Donna about a new NFT marketplace called Toko.
So I'm not technical. So if you have any technical questions, Adam and Gabriel will be in the chat to answer anything you have there. For those of you that don't know, Toko is basically an NFT creator and marketplace that we are building. The reason why we're building it is because at the moment NFT standards they're designed in a way that is more for backwards compatibility rather than thinking about how awesome NFTs could really be. There's not that much support for collections once they're live at the moment, and there's been several issues which have been well documented about people losing their assets, security issues, and collections just disappearing because the cycles aren't updated. So basically we are going about this completely differently, and we're just going to rethink NFTs from the ground up. Like basically what can it possibly be, and try to also address the existing issues so that the creators have control. And there's full transparency, and it's very much a collaborative effort with the whole community. So we've got quite a positive community support at the moment. We have over 10 existing NFT collections that are ready to onboard to Toko. And so we just need to build it. This is the basic project creation and minting flow. So you get some idea of how you're meant to create NFTs. So to start with, you create a project, and this could be, for example, dragons. And then you create a collection, which, using the dragons example, this could be magic potions, it could be dragon eggs, it could be weapons, whatever you want to subdivide them as, basically. Once you create a collection, you then create your NFTs, and you set rule ranges. I'll show this in more detail when I get to the demo. And then you set the current values. Once you're happy with your NFTs, then you assign them to a mint, you schedule the mint, and then the NFTs go live. Post-mint, you are limited as to what you can change within the collection itself. You can add new NFTs, you can fix typos, and you can change the current revenue distribution, but you can't change the ranges that you originally added. So you can continue to add new mints and push out more NFTs as long as you don't go over the maximum number of NFTs that you said you would create. You can then create additional collections and so on. For the NFT holder themselves, once they've claimed an NFT, they've got a few options. They can store it in a wallet like WASI. They can use it, which means they can either import it in a game or it can give you entry to a concert. That's really, it depends what the creator has set it up to do. You can also list it for sale, and you can transfer it to someone else, which basically means you can give it to someone. The secondary marketplaces are quite different, the way that we're doing it. They are referrers. They never get control of your canisters. And the fee is controlled by what the creator set when the NFT was minted. Right, so the demo. So this is currently what we have, and you can see the URL, so I'm sure some people will go there. So this is a collection that we made for dragons. You can see there's permissions. So if you have people like, I don't know, you have a file upload monkey, for example, then you can give them permission to add like tokens. And if you want, you have like if it's an art gallery, you would probably want more than one person to manage it. It's completely optional. You don't have to have that. Then something that's quite different with Toko is we have a Toko-wide rarity system. This is really to ensure that rarities have some meaning. If you've played Overwatch, you've probably got like 20 legendaries in the first blind bag, and it's just kind of ridiculous and meaningless. So here, the rarity is really scarcity, and we limit it. So if you've only got a small set, then you're not going to be able to create any like mythical rarity items. You can change everything. You can change the name, you can change the color, you can change the description, but what you can't change is the minimum number of tokens you need to unlock that. Then you create a collection. So there's a collection there for dragon eggs, and you have a thumbnail. You then have your NFTs, which you can click on and you can edit these. Then the exciting thing is the rules, which I'll go on to next. So here we're actually going to add functionality. So you have fungible and non-fungible tokens within the same collection. So this is basically where you say, do you want to have issue numbers? Do you want to, and you put in the max number of tokens per collection. And also if you want to have tokens, essentially fungible things, then you say how many you want there and so on. The rules is the bit that makes Toko really special, to be honest. Here when you set up the collection, you basically say what is required to claim it, which you can either use ICP or an ICRC token, and you literally specify everything, all the percentages. You can add extra payment addresses if you want to go to pay someone else that helped you. Then there's claim requirements, where you can basically say that in order to claim something, someone has to have have a certain amount of ICP staked, and for a certain amount of time, they have to hold a specific SNS token, or they have to hold a specific NFT from your collection. The claim restrictions is currently using Decide AI's proof of humanity, and that basically says that you can only have X number of tokens per actual verifiable human. You can do claim rewards, so you can give ICP or ICRC tokens. The revenue distribution is probably the most interesting thing for anyone that's building NFTs. So you set the sales fee, you set a minimum and a maximum range, and then the current price. So when you do it, when you set everything up, then you basically have to decide how much are you going to be comfortable with giving away, and then you adjust it accordingly. Same with the creator. You can optionally give stuff to the Motoko DAO. You don't have to. And you do have to put like a certain percentage to maintain your cycles, which you obviously have to do, otherwise you don't have any canisters. And then you can add additional beneficiaries. And the last thing that I'm going to show you right now is the transfer rules, where you can basically decide whether this NFT is essentially soul bound, so you can't trade it, whether it's got like a countdown, so it can only be traded a certain number of times, or whether it can be transferred as many times as you like. Okay, so I'm going to go back to here. We use Mimic, so we can do cool stuff. That's open source ORM and query engine. And so there you go. Ooh, Rust. Yeah, this is really cheesy. I meant to take this out, actually. So the Toko Creator alpha launch should be late July, and we're shooting for September for the Marketplace alpha launch. But if we get it finished before, we will launch it before. So then I guess what's next? So the generated layer support is basically creating NFTs the way that most NFTs are currently created, where you have traits and they have rarity and so on. Then there's splitting and merging, where you'll be able to basically combine multiple NFTs to transform into another one. or split it apart. Auctions are actually pretty far along with auctions, but yeah, so we can have runtime based or reserve auctions, and they're just natively supported. They're actually built into the NFT, and we can do blind auctions using vet keys. Creators are going to be very important in Toko, so we're going to do creator spotlights where we highlight the particular artists or companies behind them, and really try to get people interested in their collections. As I said, fungible tokens, also state, which is pretty exciting, to be honest. There's going to be complex state machines, so you could, in theory, create Magic the Gathering. And so that would be pretty awesome. Then there's also dynamic ownership, which you could, for example, rent out your NFT. You could have a boomerang concept where you've got an NFT and you throw it away and it will always come back within like 24 hours. There's also like the king for a day concept. So, this could be an NFT that's given out to people within a community, and it gives them special either PvE or PvP bonuses or things like that. Anyway, so that's what we're doing next. So you've got quite a lot on our plate, but we're getting there. And if you're interested, you can follow us on Twitter or OpenChat. And thank you.
Yeah, thank you very much, Donna. It looks really amazing. I can't wait to be the king for a day. And that's already it. We're at the end of this week's Global R&D. I'll hope to see you around for the next edition, and have a good rest of your day. See you.